GCSE Astronomy, Topic 11, some smaller solar system objects now, SSSOs, I'm going to talk about. Now, the Kuiper belt, it's a donut-shaped ring of icy objects beyond the orbit of Neptune. So Neptune is at about 30 AU. The Kuiper belt is from 30 AU to about 55 AU. And then after that, it gets thinner and thinner and becomes the scattered disk, which is not very much there, basically. So the Kuiper belt is beyond Neptune, thousands and thousands of tiny, well, some of them quite big actually, icy objects. The Oort cloud surrounds the whole solar system, and it is massive. It's very, very big. It's about a diameter of about 1 light year. Okay, it could extend up to 100,000 AU, which is about a quarter of the way to the next nearest star. And it is a spherical shell and billions of icy objects. Some of them, well, most of them very, very small, but some of them quite big. We're talking tens of kilometers. And the solar system is in the middle of this. That's the Oort cloud. Asteroids. Now, to be an asteroid's a big lump of rock. It's there are millions and millions of them, and these rocks, to be an asteroid, it has to be bigger than 1 meter in diameter. Most of them are in the asteroid belt, which is between Mars and Jupiter. There's lots of them in other places in the orbit of Jupiter. There's quite a few asteroids. And there's other asteroids which are just bodding around in space. Okay, the largest asteroid is Ceres, which is 1,000 kilometers in diameter, and it's classed as a dwarf planet, Ceres, discovered by a Polish monk. What are asteroids? They're bits of rock that never grew big enough to become planets and then shattered into pieces, and we've got lots and lots of lumps of rock in a certain region of space. Meteoroids are smaller pieces of rock. If it's less than 1 meter in diameter, then it is a meteoroid. And a meteoroid is just a small piece of rock in space. If a meteoroid enters the Earth's atmosphere, then it will get very, very, very hot. It will burn up due to air resistance, lots of heating effect, and that is a shooting star, is a meteor. And then if it manages to get all the way to the surface of the Earth, that's a meteorite. So meteoroids in space, a meteor is a shooting star, a meteorite hits the surface of the Earth. We get meteor showers in the same place every year. And this is because as comets orbit around the sun, they leave a trail of lots and lots of little bits of rock. So when the Earth goes through this trail of debris left by a comet, then we will get a meteor shower. And that's why the same meteor shower happens at the same time every year. It's when the Earth is going through this patch of debris left by a comet. What are comets? Comets are big, dirty, rocky, dusty balls of ice, big rocky snowballs. There are short period comets. A short period comet, the period is less than 200 years, and it's thought that they come from the Kuiper belt. And then there are long period comets. Their period is greater than 200 years. Some of them have periods of thousands of years, and they're thought to originate in the Oort cloud. They have very interesting orbits. Their orbits are very eccentric. In other words, they're very, very far from circular. Sometimes they're very close to the sun. Most of the time they're very, very far away. Their orbits are very inclined to the ecliptic. So their orbital plane is tilted to the ecliptic by quite a bit. And very often their orbits are backwards. Just about everything in the solar system, looking from above, goes around anti-clockwise, goes around the sun anti-clockwise, but comets don't. A lot of comets go around clockwise. And then these three bits of evidence suggest that comets come from outside the solar system, or at least outside the inner solar system. The anatomy of a comet: there's the bit in the middle, which is the nucleus, and then as it gets closer to the sun, a lot of the ice will start to evaporate and the comet will get an atmosphere, which we call a coma. And then it leaves behind two tails. There is a tail that always points away from the sun, and that's due to the solar wind, and that's called the gas tail. And that's made up of charged particles, because the solar wind is made up of charged particles, so it drags away all of these other charged particles, and that's the gas tail. And then there's a very, very large dust tail, which is curved. The reason that it's curved is because it's so big, the end of the tail is further away, significantly further away from the sun, and so it's in a slower orbit, and you end up with a curved tail.